Hello, everyone. So today we're going to be talking about catchment area resource optimization using AnyLogic. A quick brief about Lean. Lean is a company that is focusing on developing and empowering the health sector in Saudi Arabia. We focus on four themes: business solutions, healthcare, population health, ecosystem integration. And part of the business solutions, we develop AI models as well as simulation models. So why catchment area? Basically, in the healthcare system right now, there's a transition or revolution in Saudi Arabia. The establishments used to all report, the governmental health establishments all report to one entity, the Ministry of Health. And now they're transitioning into clusters. Each cluster is responsible for a number of establishments. So the planning for resources, locations, type of care for each establishment is part of legacy planning, and it does not serve the purpose of today or the future needs. So we built a simulation model, first an optimization model to assign individuals or beneficiaries to the primary health care, PHCs, as well as build a simulation model for capacity planning and to test multiple possible scenarios. So this simulation covers 33 million individuals or beneficiaries, as well as 2.7K PHCs, or primary health cares, and there's 21 cluster. What would happen if we do not intervene? First, congestion slash overcrowding. There are some establishments that has high demand, but not enough resources. The second problem we may face, resource wastage. Some primary health care are in areas where there's no demand. So there's very low utilization for such primary health care. So there will be wastage of some resources. And last is bad patient experience, whether it's because from the waiting and overcrowding, or whether because they have to go to primary health care that are far away or not convenient to them. So the objective is to assign beneficiaries to the primary health care, the PHCs, using simulation models that has two agents, the beneficiaries and the establishments, to simulate or represent the supply and demand. So the first agent, the beneficiary, the second agent is the PHC, as we mentioned. We will have all the beneficiaries and PHCs inputted in the model, and then each individual or beneficiary would be assigned to a primary health care, and then we will be estimating the demand throughout the model. And with that, we will get four main outcomes. The beneficiary assignments, you can extract it from the model and share it with the Minister of Health, so they can communicate with the beneficiaries that this is the assigned primary health care for you. The second is the daily demand for PHCs and PHC utilization that can be shared with the primary health care themselves, so they can do better planning with the capacity, and number of visits per patient. So the first agent has four main inputs that impact the overall demand. Chronic disease, whether the beneficiary has chronic disease, diabetes, hypertension, and so on. The absence or presence of the presence of chronic disease will increase the expected visits of the beneficiaries. The second input is the insurance. Whether the beneficiary has insurance or not, because it tends that in Saudi Arabia, people who have insurance, they do not often go to primary health care. They would go to hospitals or the private sector. And the presence of insurance presence of the insurance will decrease the expected visit. The third input is the citizenship. It is more likely for citizens to go to primary health care than non-citizens in Saudi Arabia. So the presence so the citizenship increase the expected visits. And lastly is the visit rate. We input the historical data for beneficiaries, the last 3 years of their visits to primary health care as part of the input of the model. There are other inputs such as the geospatial location or the location of the beneficiaries. All of these inputs are inputted in the optimization model as well as the simulation model. The second agent, the primary healthcare or the PHCs, has two main inputs: the geospatial, the information about the location of the PHC, health cluster region, as well as the exact latitude and longitude of the PHC. The second input is the capacity, the daily slots in the primary health care, as well as the occupancy rate or occupancy threshold. Some primary health care has, let's say, an 80% utilization max. Just in case of an emergency, they will not accept any beneficiaries if they reach that threshold. This is a very high-level view of the model. So, as you said, it's an agent-based simulation that contains two agents, the PHCs, with the parameters geographical location and visits capacity, and the second agent, the beneficiaries, that includes the parameters of geographical location, the chronic disease status, insurance, citizenship, and visits rate. So the first step at model time equals 0, we will calculate the driving distance between the beneficiaries and the PHCs. And then each beneficiary will be assigned to the nearest PHC unless they have a preference from their historical visits. If a PHC has no more capacity, the beneficiaries will be assigned to the second nearest available PHC. And with that, we will assign all beneficiaries to PHCs. Step 2, at every model time, we will take random beneficiaries to visit their assigned PHC. If their assigned PHC reach the maximum occupancy threshold, they will be transferred to the nearest PHC. And of course, the total visits of beneficiaries cannot exceed the maximum expected visits for each beneficiary. Step 3, the outcomes. We will have a main dashboard to show the capacity and demand as well as the utilization. And multiple what-if scenarios. For example, what if we set an occupancy rate threshold to all PHCs? What if there is an increase of chronic disease in the population? What if there's a change in the insurance rate? And what if we open or close PHCs? And what if we increase or decrease the visits capacity in some PHCs? So I'll be showing a demo of the model, the AnyLogic model, that contains dummy data just for demonstration purposes. So first, we will click on Start. We will show on the map two clusters with dummy PHCs. And then we will see the number of PHCs, daily visits, and total capacity in the main view, as well as the utilization. We can click on certain PHC, and then we will see the page of that PHC, which will show us the PHC utilization as well as the average utilization, and some of the information about the PHCs, including the capacity that we can change, and the threshold utilization, and we can close that PHC if we want to test what will happen. In the main dashboard, we have a few filters, as well as the distribution of PHC's visits and PHC utilization. In addition, we have the PHC visits versus the capacity and the of each PHC. So we can see whether PHC has a gap between the demand and the supply. In the page of what-if scenarios, we can adjust the chronic disease rate in the population. We can adjust the insurance rate in the population, as well as the occupancy rate threshold for all PHCs. We can also add a new PHC if we click on that. We can add a few information about the PHC, including the latitude and longitude, and the capacity of that PHC that we would like to add. And in the comparison page, it will show us a comparison between the baseline and between any scenario that we added. So let's test a scenario. Let's say the population rate is increased. We will see a huge spike in the visits, and we will see that there's a difference in the occupancy rate between the baseline and the scenario that we added. Let's say we want to solve that problem. We can click on the PHC and one of the PHCs. As a scenario, we can, let's say, just add capacity to one of the PHCs instead of adding a whole new PHC. Let's see what would happen. We can see now in the occupancy rate that they are back to how it used to be before we added the population, the chronic disease rate. So there are three main key values of this simulation. First, it is risk-free environment. It is data-driven decision, and it helps in complex system analysis. It is provided to multiple stakeholders and decision makers in different levels, so they can take decisions regarding to enhance the service availability, minimize resource wastage, and improve patient/provider experience. So in Lean, we built over 30 models to different clients, and we found it to be challenging to productionize some of the simulation models due to multiple reasons. One of them could be trust and capabilities, that it would actually help them in taking decisions, help decision makers or clients in taking the right decisions, or the cost of the operation for them to operate such models. So these are few lessons that we learned throughout the years. To fix the trust, we need to identify the pain by identifying the strategic pain, identifying a supporting stakeholder, and we do not discuss money at early stages. And to establish stakeholders' trust, we involve stakeholders in the model conceptualization process for them to understand how it works exactly, as well as build a proof of concept. We always build proof of concepts to help them solve a small scale of the problem before we scale up. And then we will document our success with that proof of concept. We do not hide any limitations, whether it's in the proof of concept or in the bigger scale solution or model. And to scale up or to sustain the value, we build the business case and we enhance the user experience. We found that to be very important. When we do not put enough effort in the user experience, some clients would feel that it is too advanced or it is for academic purposes rather than the business people can use. So we put a lot of, sometimes we even hire experts in UI, UX to help us build or design the model, let's say. And then we also pick the right operating / business model, whether it's build, operate, maintain, build, operate, transfer, or build, transfer. The last thing, which is very crucial, is customer privacy matters. Some customers would not feel comfortable to share any data, especially if we're dealing with the government. So what we do is we do not ask them for any data. We just ask them, what kind of data do you have and what limitations do you have in your data? And then we build the model with dummy data. And in the database, we add tables that match their structure of data. So all they need to do is basically update the data and then run the model right away. And this is how these are the lessons that we learned to productionize such models. Thank you for listening.
Thank you for that great talk. Couple of questions. So the first one is, you spoke, I think it's really important that you touched on this idea of building confidence with the stakeholders that you're working with. In healthcare, I imagine that there's many different types of stakeholders, policy, clinical, maybe public health. Do you have experience, or would you be able to share about kind of the differences? Like, I don't know which parts of those stakeholders you've worked with, but in my experience, they have different things to look for. So I'm wondering if you have some thoughts on how you've worked with the different needs of the different kinds of stakeholders in a health setting.
So when it comes to decision makers, one thing that we usually focus on is solving a small part of the problem before we even talk to them. Before we even reach out to them, we would ask all the questions about the problem and then build a POC. And after we build the POC, with hopefully a show of a small impact of the model, we will reach out to them. That's when it comes to decision makers. When it comes to clinical operational people, we would involve them from the beginning. We will show them how it would work, how the model exactly would be operating, and then after we build the POC, we will let them themselves test different scenarios before we scale up.
Great, and maybe that touches a little bit on the second question, but because I mentioned, I know how you talked about this data privacy issues with healthcare, with government, and so on. So when it sounded like what you said was you sort of understand the kinds of data they have, you build the model with dummy data, and then you give them the model, they can put their own data and run it internally. So how do you empower, in healthcare, no doubt, we understand that the quality of the model is going to be different from the real world. Like, the model is not going to capture all the complexities of the real world. So how do you empower the client to be able to interpret the results of the model without imagining it's like this magic 8-ball?
Very true. So not all cases you can do such approaches. In some cases, there will be a lot of data enhancements before you input it to the model that you need to analyze it before building the model. But in many cases, in some cases, let's say, such approaches would be valid. So we will put guidelines or KPIs before we give it to the clients, and we will tell them that no matter what's your data, you should expect these things. If you do not, then there's a problem. If there's a problem, whether we get the data, help them solve any data quality issues, or whether see another approach. Okay? Thank you very much.